Hi, welcome to another Super Space Theory video, and in this video I'm going to be talking about infinity in the math that we already have regarding space and dimensions. So when we look at the math of, let's start with a black hole, and here I just brought up a page that is talking about the math describing various kinds of black holes. The point being that there are mathematical equations that describe the curvature of a black hole that leads to infinity. Now, in physics, we would say an infinitely small or infinitely dense point, but the math isn't actually talking about a point. It's simply stating that infinity is there at the particular part of the equation where the curvature or the density, but let's just say the curvature of gravity becomes so pronounced that it reaches infinity. Now, the same is the same could be said for the math of a singularity. And let's just look at a Wikipedia page real quick. Singularity predicted, the initial singularity is a singularity predicted by some models of Big Bang theory to have existed before the Big Bang and thought to have contained all of the energy and space-time in the universe. The instant immediately following the initial singularity is part of the Planck epoch, the earliest period of time. And so in the math, but let's just read this and see if this applies. Many theories in physics have mathematical singularities of one kind or another. Equations for these physical theories predict that the ball of mass of some quantity becomes infinite or increases without limit. So there we see it. So where these predictions occur, where things become infinite due to mass or curvature, this is in the mathematics. And we allow that for black holes and for the singularity that existed before the Big Bang in our theories, whether or not those are actual realities or not. So we allow for infinities within these theories. We do not allow for infinities when, for instance, we are trying to combine general relativity with quantum mechanics, and as we try to bring general relativity regarding space-time at the macro scale and the curvature of gravity into the quantum realm, we find infinities everywhere. We don't allow for those. We say that it's a breakdown in the theory. So let's go over this. In the idea of a black hole, the math is telling us at the point where the curvature becomes pronounced enough, because of the breakdown of mass is our mechanism, we reach infinity. And it does not talk about a point. This infinity is actually a direction, as we know from superspace theory. My point here is that our idea of a black hole as mass which breaks down, it becomes so massive and unstable that it breaks down and reaches this point of infinite density, that's the mechanism. The conceptual reality, it's a concept, it's a theory, that we've decided will allow that infinity to exist. And the same with the Big Bang, when we are tracing the universe back smaller and smaller and smaller, although the math is not saying the universe is getting smaller. But when we trace the universe back, we allow for that infinity to be reached in Big Bang Theory. But that very same kind of infinity is the same infinity in the math that exists when we are trying to combine general relativity and quantum physics. What it's telling us is that infinity does exist at every point in space where we curve inward far enough. So if we have a black hole here, and the math says if the curvature becomes extreme enough, we reach infinity, every point in space, if the curvature of gravity curves far enough to move into the quantum realm, we reach infinity. The math gives us infinity. It gives us infinity because every point in space can hypothetically move in this fourth spatial direction of the fourth dimension. We can't understand this because we are stuck here in this field, which is a 2D analogy for our 3D space. We only see this, and we think things are bigger or smaller here in this field of space, and that smaller things are always inside of bigger things here in this sheet or field of space. But when we see that the realms of the very small, the fundamentally smaller realms of quantum physics, the subatomic, are actually existing in fields that are outside of our own 3D field of space, this is us, then we can see that this infinity in the math is not talking about something right here. It's talking about a change in direction that can exist at every single point in space. Any point in space, if we curve inward far enough, curves into this fourth spatial direction of the fourth dimension, what we think of as the realms of the very small. And that is what the math actually tells us when we are trying to combine general relativity and quantum mechanics. It's the same math in a sense, not the same equations, it's the same mathematical concept as we have in black holes and singularities. Infinity can exist at every point in space because it's a fundamentally different direction, moving in what we think of as the realms of the very small, but what's actually the fourth dimension. Thank you for watching the video.